Question 17, we have a Venn diagram showing a bunch of numbers in three sets, A, B, and C, and then we've got this lonesome 8 on the outside that doesn't belong to any of them. Write down the numbers that are in the set A. So in other words, what numbers are in the A circle? If we look, we can see 6, 4, 2, 12, 1, and 3. You don't have to do this, but putting them in order is what the answers are going to look like. If you have them in a different order, it's okay, you'll still get the marks, but this is what you're going to see in the mark scheme, so I'm just going to write it like that. 1, 2, 3, 4, 6, and 12. Remembering you got your curvy brackets that stipulates that you are in a set, and that's part 1. Part 2, B union C. The union is basically anything that is in either circle B or circle C. So it doesn't matter where it is. It doesn't have to be in both. It could be just in C. It could be just in B. We don't even care about whether or not it's just in A. We're not interested in A for this. It's just what's inside that pink region there. So all of the numbers that are in there, putting them in numerical order, we have 1, 3, 5, 7, 9, 10, and 11. Next part. Brian writes down the statement A intersect C equals the empty set. So this symbol here means the empty set. Another way of describing it is that when you end up with this, there's nothing. That is the symbol for nothing in set notation. We can't use a 0 because a 0 is an actual number like a 6 and a 4 and a 2. So we have this Danish looking 0 here to signify the empty set. So what it's saying is that there is nothing in the intersection between A and C. Well, let's look at what A and C actually are. A is this circle here, and C is this circle or this set here. The fact that they don't intersect basically guarantees that there is no intersection. There's nothing that's in both A and C. Therefore, Brian is correct. So there is no intersection between sets A and C. You could also say there is nothing in their intersection, but by default, if there is no intersection, then there's obviously nothing in it. And I'll give the mark for that. Next part, one of the numbers in the Venn diagram is picked at random. Find the probability that this number is in the set C dash, the complement of C. Basically, what is outside of C. So this is our circle C here in green. We're looking for everything that is not in C. So we're interested in all of this shaded bit here. Actually, a better way of doing that. All of these numbers here that I'm highlighting, these are the ones that we're interested in because these are part of the opposite of C or not C or the complement of C. Everything except 5 and 10 basically. Now, the question didn't ask us to list it, it said find the probability. So we need to figure out how many of these values are not in C. Or in other words, how many numbers have I put a blue dot on? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And out of a total of 10 plus 2 for 12. So we have 10 out of 12 is the probability, which simplifies to 5/6. If you don't simplify the fraction for probability questions, you're okay with that. So either of these would be correct, but of course 5/6 is technically more correct, if that makes sense. Done.